Welcome to the General Chemistry 1 class. This section is on chemical reactions and chemical equations, focusing on chemical equations. In this lesson, we will write equations from chemical reactions and balance the given equations. A chemical reaction is a process in which a substance or a mixture of a different substance are converted into new substances. Just like burning of wood is an example of a chemical reaction in which the materials in wood are converted to gas, soot, and ash. A chemical equation is a representation of a chemical reaction which shows the chemical formulas of the substance involved. As shown in the diagram, a chemical equation consists of reactants and products. Reactants are the reacting substances before a reaction takes place. Products, on the other hand, are the substances generated right after the reaction takes place. In writing a chemical equation, reactants are on the left side, while products are on the right side. The reactants and products are separated by an arrow whose head is pointed toward the product, indicating the conversion of reactants to products. Let us consider the reaction involving the formation of ammonia from nitrogen and hydrogen gases. To write the corresponding chemical equation, the reactants are nitrogen and hydrogen and are written at the left side of the chemical equation. Note that the chemical formulas of the reactants are separated by a plus sign. The plus sign signifies that more than one substance is the reactant or product. Ammonia, on the other hand, is the product, hence written at the right side of the equation. Another thing to take note in a chemical equation are the coefficients: 3 in hydrogen and 2 in ammonia. Coefficient comes before the chemical formula of a given substance to indicate its quantity. If no coefficient is written, it simply means a coefficient of 1. The equation can be read as one nitrogen molecule reacts with 3 hydrogen molecules, yielding, producing, or forming 2 molecules of ammonia. Another way is by expressing quantities in moles, such as 1 mole of nitrogen molecule reacts with 3 moles of hydrogen molecules, yielding, producing, or forming 2 moles of ammonia molecules. For simplicity, when using the unit mole, the word molecules as well as atoms, ions, or particles is no longer mentioned. Physical states of reactants and products can be indicated in reading or in writing chemical equations. This is very important when one is to carry out the actual reaction. Replacement with the same substance but of different physical state may not lead to the desired or expectation reaction or expected reaction. The physical state are written after the chemical formula and are indicated by symbols S for solid, L for liquid, G for goat, and AQ for aqueous substance or those dissolved in water. For a complete understanding of how the reaction takes place, conditions are indicated above or below the arrow. The conditions involve temperature, pressure, and other substances that facilitate the reaction. In writing a chemical equation, one must make sure that it is balanced. The number of atoms for each element on the left and right side is equal. When a given chemical equation is not balanced, the coefficient of the substance can be adjusted. How coefficients are adjusted is usually done by trial and error method approach, or this approach is also known as balancing by inspection. Before you proceed to balancing chemical equations, make sure that you can write chemical formulas for elements and compounds given their names. Writing chemical formulas are necessary in writing chemical equations. Example number 1. Balance the following equation. Aluminum reacts with sulfuric acid to produce aluminum sulfate and hydrogen. Here is the chemical equation for the reaction. For this discussion, we will not give emphasis on the physical states of the reactants and products, so we may not indicate them for now. Let us check whether the reaction is balanced. To check whether the equation is balanced, let us count the number of atoms for each element on the left and right sides of the equation. The reaction contains aluminum, hydrogen, sulfur, and oxygen. For aluminum, there is an atom on the left side and 2 atoms on the right side. For hydrogen, there are 2 on both sides. For sulfur, there is 1 on the left side and 3 on the right side. For oxygen, there are 4 on the left side and 4 times 3 or 12 on the right side. From here, we can see that the equation is not yet balanced. In adjusting coefficients, do this first in compounds. Let us start balancing sulfur in the equation. This can be done by adjusting the coefficient of sulfuric acid from 1 to 3. With this, the count of hydrogen, sulfur, and oxygen on the left side will be affected. The number of the hydrogen is now 3 times 2 or 6 for sulfur becomes 3 times 1 or 3. And the oxygen is 3 times 4 or 12. At this stage, hydrogens and aluminum are not yet balanced. It is an advantage that the coefficient of the elements are adjusted last, since no other element would be affected. There are 6 hydrogens on the left side and 2 on the right. To adjust the count on the right, we can place a coefficient of 3 for hydrogen gas, increasing the count to 3 times 2, which is 6. Now, only aluminum is not balanced. To balance aluminum, we can adjust the coefficient of aluminum to 2. This will make the number aluminum at the left side increase to 2, which is the same at the right side. Now, we can see the equation is already balanced. Congratulations! You did a great job. So now let's proceed to example number 2. Write a balanced equation for the reaction of butane with the chemical formula of C4H10 with oxygen to form carbon dioxide and water, shown in the chemical equation corresponding to the given equation. Again, you must recall the tips and the knowledge on how to write the correct chemical formula from the chemical name. Elements present in the reaction are carbon, hydrogen, and oxygen. Let us count the number of these elements in the equation. For carbon, there are 4 atoms on the left side and 1 on the right side. For hydrogen, there are 10 on the left side and 2 on the right side. And for oxygen, we have 2 on the left side and 3 on the right side. As shown, the equation is not yet balanced. We can start balancing carbon by adjusting the coefficient for carbon dioxide to 4, changing the count of carbon from 1 to 4 and oxygen from 3 to 9. As we can see, the equation is not yet balanced. The next element that can be balanced is hydrogen. We can adjust the coefficient for water to 5. From this, the hydrogen count is 5 times 2, which is 10. Also, oxygen on the right side has been affected by the presence of coefficients 5 in water. The number of oxygen now is 4 times 2 plus 5, which is 13. So far, only oxygen is not yet balanced. In balancing oxygen, we can increase the coefficient for oxygen molecule, since there are 13 oxygens on the right side. We must put a coefficient for oxygen molecule that will make the count 13 on the left side, and that is 13 over 2. Now, we can see that the equation is balanced. However, in writing equations, coefficients are customarily written in their smallest whole number ratio. To cancel the denominator 2 in the coefficient for oxygen, we can multiply all the coefficients by 2. By multiplying all coefficients by 2, equation remains balanced, but the coefficients are now simplified to their smallest whole number ratio. Congratulations, you did a great job. Now let's proceed to example number 3. Write a balanced chemical equation for the reaction of ammonium sulfate with iron 3 chloride to yield ammonium chloride and iron 3 sulfate. The chemical equation for the reaction is as follows. Let us determine if the equation is already balanced. In this example, counting of atoms can be done by group. For instance, an H4 group of atoms can be counted as 2 on the left side and 1 on the right side. On the other hand, there is 1 count of a sulfate group on the left side and 3 groups on the right side. For iron, there is 1 on the left side and 2 on the right side. And for chlorine, we have 3 on the left side and 1 on the right side. Let us start by balancing iron. By adjusting the coefficient for iron, 3 chloride to 2, the iron atoms becomes 2, while chlorine becomes 6. At this point, iron is now balanced, but chlorine is not. To balance chlorine, we can adjust the coefficient for ammonium, ammonium chloride to 6. By doing this, chlorine on the right side matches the count of chlorine at the left side. Moreover, NH4 group on the right side increased to 6. To match the count of NH4, we can adjust the coefficient for ammonium sulfate to 3. By doing this, we now have 3 times 2 or 6 NH4 groups on the left side. This group is now balanced. Also, the count of SO4 at the left side increases to 3, which matches the count of SO4 group on the right side. At this point, the equation is already balanced. Some important notes in balancing chemical equation. First, in balancing chemical equations, only coefficients can be adjusted. Second, never attempt to adjust the subscripts as this will change the identity of the substance in the given equation. Third, start from adjusting coefficients for compounds before dealing with elements. And lastly, as a convention, make sure that the coefficients are in the smallest whole number ratio. To summarize, chemical equation is a notation that represents a chemical reaction involving reactants and products. And in a chemical equation, substances involved in the reaction are stated in the form of chemical formulas. Chemical equations must be balanced. This means that for each type of atom, there is the same number of that atom on the reaction side as there in the product side. Here is our bibliography, and thank you. God bless.